Welcome to qnawire.
Alright, great. An experiment is performed here. We are looking at a mass of 50 kilograms, right? And another mass here of 100 kilogram. Call that M1, M2. Radius of 0.2 meter. And we are looking at Ri, call that RF of 40 meters apart. So they gravitate towards one another. We can find while linear momentum is conserved when the centers are 20 meters apart. Perhaps you need to find the speeds here. So therefore the first thing to figure out is quite straightforward, because in this relationship we know that Ke, kinetic energy initial, plus potential energy initial should be equal to kinetic energy final plus potential energy final, which means that G M1 M2, this should be M1 M2s, right? Multiply by 1 over RF minus 1 over Ri should be equal to half of M1 V1 squared plus M2 V2 squared. Okay. So from the law of conservation of linear momentum, M1 V1 should be equal to M2 V2. So therefore, if you factor in this equation, V1 squared should be equal to 2G M2 squared over M1 plus M2. Multiply that by 1 over RF minus 1 over Ri. Okay, and if you expound these, if you substitute, you're going to get 2 into 6.67 into 10 to minus 11 Newton meter square per kg, multiplied by 100 kilograms over this is 50 plus 100. Okay, multiply that by 1 over 20 minus 1 over 40. Okay, so what we expect here is, and so you get that as a square root of it of 1.49 into 10 to minus 6 meters per second. Okay, so therefore the speed of the 100 kilogram sphere will be given as V2 into V1 M1 V1 over M2, factoring in at 50 over 100 multiply 1.49 into 10 to minus 6. Okay, and you'll have a velocity of 7.45 into 10 to minus 7 meters per second. You can do the same for the other sphere of the other okay. So the magnitude of the relative velocity of the two spheres, therefore you can go ahead and say Vf will be equal to V1 plus V2, which is 1.49 into 10 to minus 6 plus 7.45 into 10 to minus 7. Okay, and you get your answer there in meters per second. Moving swiftly to the other bit of the question, the distance of the center of the sphere proportional to the acceleration. Remember that x1 over x2 should be equal to a1 over a2 in that regard. Okay, giving you m1 over m2. So therefore we can make the sphere that's you can assume that these spheres make contact with one another, where x1 plus x2 plus 2r should give you 40, right? That is x1 plus x2 plus 2r to give you 40. Okay, that's an assumption you can make here. And also you can go ahead, if you proceed and solve it, and you can get the point of contact in terms of R. Okay,